A few times every night, an astronaut on the International Space Station closes their eyes and sees a flash of light. There's no lamp behind it, no screen, nothing in the cabin that could have made it. Crews have reported these flashes for over 50 years, and they come most often as the station crosses one stretch of the planet, the sky above the South Atlantic. Something out there is reaching through the walls of a sealed spacecraft to touch a human eye. So what is it, and why only here? I want to walk you through the strangest soft spot on Earth, and I want to be careful with it, because this is a story that gets sold to you at a scream. Search for it, and the feed fills up with the same warning, over and over. The planet's magnetic shield is collapsing. The poles are about to flip. This is the opening scene of an extinction. Underneath that noise is a real thing, measured by real satellites, that genuinely is changing while we watch. There are three parts to this: what the weak spot actually is, what it's doing to the machines and the people who pass through it, and the harder question hiding under all of it, which is whether any of this means what the internet is telling you it means. One of the scientists tracking the field said something to CBS News that I keep turning over. He said there's something special happening. Sit with that sentence for a minute, because what he actually meant only lands once you've seen what sits underneath the ocean down there. To understand why a hole in the sky matters, you have to understand what the sky is made of here, and that story starts about 1,800 miles under your feet. Earth has a magnetic field, and it isn't a decoration. It's the reason the air outside your window is still there. The sun throws a constant wind of charged particles at us, radiation that would strip an atmosphere down to bare rock over millions of years, the way it very likely did to Mars. Our magnetic field catches most of that and sweeps it around us. It's a shield, and we live our whole lives inside it, without ever feeling it. That protection is generated by the planet's own core. Down at the center is a ball of solid iron, and wrapped around it is an ocean of liquid metal, thousands of miles deep, hotter than the surface of the sun, and always moving. As that molten iron churns, it generates electric currents, and those currents generate the field. Scientists call the whole engine the geodynamo, which just means the planet making its own magnetism out of moving metal. And here's the first thing worth sitting with: the field isn't neat. In the tidy picture we all learned in school, Earth is a simple bar magnet, poles top and bottom, the field even on every side. The real one is lumpy, lopsided, and always shifting, because the ocean of iron making it is lumpy and shifting too. That lopsidedness is the whole story. The magnetic core of the planet is tilted about 11 degrees off the axis we spin around, and it's shoved off-center by something like 300 miles, so the shield isn't the same thickness everywhere. And there's one place where it sags lower than anywhere else on Earth. One place where the protection thins out and the radiation gets closer to the ground than it has any business being. That place sits over South America and the South Atlantic, and we have a dry, technical name for it: the South Atlantic Anomaly. We've known it was there for a long time. When the United States launched Explorer 1 in 1958, its first satellite, the instrument on board was a simple radiation counter built by a graduate student under the physicist James Van Allen. That satellite discovered the belts of trapped radiation ringing the planet, the ones we now call the Van Allen belts. And almost immediately, there was a problem. Over one region, the counter went haywire, swamped by radiation far lower down than it should ever appear. That region was the South Atlantic. The weak spot has been sitting there, quietly, since the dawn of the space age. What's changed is that we can finally watch it move, and it is moving. This is where the alarm starts, and I'm not going to soften it, because the numbers are real. Over the last 200 years, the planet's magnetic field has lost about 9% of its overall strength, not in one spot. Globally, on average, the whole shield is running weaker than it did when we first learned to measure it. Zoom into the anomaly, and it's starker. Right in the heart of it, the field strength has fallen from around 24,000 nanoteslas in 1970 to about 22,000 today, a nanotesla being just the unit we measure magnetic strength in, and the weak zone won't hold still. It's spreading westward across the globe at roughly 12 miles a year, and it's getting bigger. Since 2014 alone, the area of weakest field has grown by a patch of the planet nearly half the size of continental Europe. Then it gets stranger. Over the last several years, the anomaly has started to split. A second weak center has opened up off the coast of Africa, so that the single dent is pulling apart into two, like a cell dividing. One of the scientists at Germany's National Geoscience Research Center, which helps track the field, said the new eastern minimum is developing vigorously. In plain terms, the hole isn't just growing, it's changing shape, and it's doing it faster than a slow geological process is supposed to move. Now the consequences, because they aren't hypothetical. Every satellite in low orbit crosses this weak spot, and when it does, it takes a dose of radiation it wouldn't take anywhere else, because the shield that normally holds those charged particles, hundreds of miles up, lets them sink to about 120 miles here, right down into the traffic lanes of our spacecraft. When one of those high-energy particles punches into a satellite's computer, it can flip a bit of memory, a stored one becoming a zero, a single corrupted instruction. Engineers have a name for it, a single event upset, and it's a daily fact of life up there. The Hubble Space Telescope can't take a single science image while it crosses the anomaly. It spends around 15% of every orbit passing through, and for those minutes, it simply closes its eyes and waits. Other spacecraft power down their most delicate parts on the way in and switch them back on when they come out the far side. And then there are the people. The space station threads the edge of that radiation belt several times a day, and the crew inside soak up far more radiation than any of us do down here, roughly a tenth of a sievert or more over a year, dozens of times the dose you'd get standing on the ground. A large share of that yearly dose comes from these few minutes crossing the South Atlantic. The hull shields them. The water tanks stacked around the walls shield them more, because water blocks this kind of radiation better than metal does. But it still gets through, and when it passes through an astronaut's eye, a cosmic ray tears a tiny track across the retina, and the brain reads it as light. That's the flash. That's what's reaching through the wall. The first astronaut to report it was Buzz Aldrin, on the way to the moon in 1969, and crews have been seeing it ever since, worst of all right here. So put yourself in front of that pile of facts, because this is exactly where the fear lives, and honestly, I don't think it's stupid. A planetary shield that protects all life. A hole in it that's measurably widening. A field losing strength century after century. The weak point splitting in two and crawling across the map. And the memory, somewhere in the back of your mind, that the magnetic poles have flipped before, that north has become south in the planet's past. Line all of that up, and the conclusion writes itself. The shield is failing. The reversal has already begun. We're living in the first chapter, and nobody in charge is saying it out loud. That's the story that racks up the views, and I understand why, because laid out like that, it's frightening. The trouble is that it's built on one assumption nobody stops to check. The idea is that a weakening field, measured over the handful of decades we've been watching closely, tells you where the field is going. And to see whether that holds, you have to do the one thing all the panic skips. You have to ask how you'd actually know. This is the piece the loud videos never reach, and I'll be honest, when I found where the scientists went looking for the answer, it wasn't anywhere I'd have thought to look. You can't just watch and wait. The core moves on a clock we don't live long enough to read. A real change in the magnetic field can take thousands of years to play out, and we've had precise global measurements for only a few decades, which is like trying to judge a glacier from a single afternoon. So scientists went at it from two directions. First, they mapped the present in far more detail than anyone ever had. In 2013, the European Space Agency launched a trio of satellites called Swarm, 3 probes flying in formation with one job: to measure the magnetic field more accurately than it had ever been measured, and it's their data, from 2014 to 2025, that shows the anomaly growing and splitting almost in real time. But the more important move was the second one. If you want to know whether today's weak spot is the start of something new, you go looking for it in the past, in rock. When molten lava erupts and cools, the magnetic minerals inside it lock into place, pointing along whatever direction the field had at that moment, like millions of tiny compasses frozen in stone. Read the rock, and you read the field as it was the day that rock was born. The technique is called paleomagnetism, the study of ancient magnetism, and it lets you reach back, not decades, but millions of years. And there was one perfect place to go looking, a tiny volcanic island sitting right in the middle of the anomaly, Saint Helena. Here's what they found underneath all of it, and it's quieter than the fear and far more interesting. The weak spot over the South Atlantic isn't a hole punched in a failing shield. It's the shape of the machine itself, and the machine runs deeper than anyone first guessed. Remember that the magnetic core is tilted and shoved about 300 miles off-center. That offset alone brings the shield lower over this part of the world than anywhere else, which is most of why the anomaly is here at all. But the deepest part of the answer is stranger. Down at the boundary where the liquid outer core meets the rocky mantle, about 1,800 miles beneath southern Africa, there's a patch where the magnetic field points the wrong way. A place where the field lines, instead of flowing up and out of the core the way they do across the rest of the southern half of the planet, curl back down and plunge into it. Scientists call it a reverse flux patch. Where that backward zone sits, it cancels out part of the field above it and thins the shield at the surface into the weak spot we've been measuring for 60 years. That's what the researcher meant by something special happening. What's going on beneath that ocean is a knot of reversed magnetism the size of a continent, churning at the top of the core, writing a soft spot onto the sky above it. And this is the one moment in the whole story where I want to stop and just say it plainly, because I find it genuinely remarkable. A smudge of backward field, 1,800 miles down in metal we'll never see, reaches all the way up through the planet, flips a bit of memory in a satellite, and throws a spark of light across the eye of a sleeping astronaut. The thing touching them through the wall started at the center of the world, and it has been doing it far longer than we've been up there to feel it. And then Saint Helena closed the case. The rocks on that island recorded the magnetic field across dozens of ancient eruptions, 46 separate lava flows, laid down between 8 and 11 million years ago. And the field they recorded here, all those millions of years ago, was already strange, already pointing oddly, already anomalous, in the same troubled corner of the globe. Long before there were satellites to be swamped or astronauts to see flashes, long before there were humans at all. The weak spot isn't new. It has come and gone in this exact place before, many times over, on a schedule far older than us. Which reframes the fear completely. If this anomaly was already here 8 million years ago, then it isn't the first act of some countdown. It's a recurring feature of how this particular planet makes its field, a knot that ties and loosens over enormous stretches of time in the same corner of the world, and the reversal everyone braces for sits on a scale most people never picture. The last time the poles actually flipped was around 780,000 years ago, and when reversals do happen, they don't happen overnight. They unfold over something like 1 to 10,000 years, sometimes longer, the field sagging and wandering and rebuilding across a span of time so long that no single person, no single civilization would ever experience it as an event. And the crucial part, the part the panic leaves out, is that a field can weaken for centuries and then strengthen again, the way this one has done again and again, without ever flipping at all. A weaker field is just the slice of a very slow process that happens to fall inside one short human life. So here's where an honest story has to turn on itself, because the reassuring version has a crack in it too, and I'd rather show you the crack than sell you a clean ending. The evidence that this is an old, recurring, survivable feature is real, but look at what it leans on. A big part of it rests on the rocks of one small island. The instrument record that shows the field weakening is only a couple of centuries long, and the really precise part is only a decade or two, and we're using it to reason about a process that moves across thousands of years. We are, in the most literal sense, judging a very slow thing from one short look, and in that glimpse, the anomaly is doing something we didn't predict and don't fully understand. It's growing, it's splitting into two, it is, in that careful phrase, developing vigorously. The researchers who model the core will tell you plainly that they can measure it beautifully, and they still can't tell it what to do next. So hold the two halves at once, because both are true. Yael Engbers, the University of Liverpool researcher who led the Saint Helena work, put the finding about as flatly as it can be put. The anomaly, she said, is a recurring feature, and probably not a sign of an impending reversal. Probably, not a promise. That's the honest shape of it. What we know is that this weak spot is old, that its cause sits at the core mantle boundary, and that a full reversal isn't something the evidence says is coming. What we don't know is exactly why it's growing and splitting right now, or what it'll do over the next few centuries. And what sits in between, the thing scientists say carefully, is that the current behavior is worth watching closely, which is a very different sentence from the shield is collapsing. That gap between watch this closely and the shield is collapsing is where the loud story lives. And there are really two claims tangled together in it, worth pulling apart. The first is that the poles are about to flip and take civilization down with them. The kernel of truth is real, the field is weakening, and a reversal will happen someday. But the leap from a 2,000-year-old weak spot to an apocalypse on our watch is not something any of this evidence supports. A reversal, if it ever comes, plays out over your descendants' descendants, thousands of years down the line, long past any life or civilization around to watch it start. The second claim is the quieter and uglier one, the whisper that the agencies know how bad it is and are keeping it from you. And that one falls apart the moment you check, because every number I've given you came straight from the European Space Agency and NASA, laid out in public with maps and press releases, because a splitting magnetic anomaly is the kind of thing that makes a geophysicist career, not the kind of thing anyone hides. So where does that leave us, honestly? The planet's magnetic field is weakening, and we can't predict what the core will do. The anomaly is real, it's growing, it's splitting in two, and it'll keep making trouble for satellites and forcing telescopes to blink for years to come. None of that is comfortable, and I'm not going to pretend the scientists have it solved, because they don't. But this weak spot is a birthmark this planet has worn before, written by a knot of backward field at the edge of the core. And the last time it was here, the world went on exactly as it is now. What the thumbnails sold you as a shield in the act of failing is really something old and slow and stranger than any apocalypse, and we happen to be the first generation with the instruments to watch it happen. What actually bothers me about all of this, and this is just my opinion, is how easily a slow, fascinating process gets flattened into a countdown. The real story, a continent-sized whirl of reversed magnetism turning 1,800 miles down, a weak spot that breathes in and out across 10 million years, is wilder and more beautiful than any doomsday cut of it. But wild and slow and beautiful doesn't travel the way fear does. Panic compresses 10,000 years into next Tuesday, because next Tuesday is what gets the click. And that trade is a bad one. You walk away scared, when the honest reaction to what's really down there is closer to awe. So here's the honest ending, and it has two halves that both stay true. The magnetic shield is not about to fail, and no one alive can promise you exactly what the core will do next. Sit with both of those at once, because that is the real state of it. This weak spot is old. It has come and gone here before, and life has crossed under it many times without ever knowing it was there. Right now, tonight, the space station is passing over that same patch of ocean again, the way it does several times before morning. Somewhere on board, someone drifting toward sleep will close their eyes, and in the dark, a thin white flash will go off with no source, a single particle that fell in through the thin place overhead, the way particles have been falling through it for millions of years before anyone had eyes up there to catch them. It's the shield doing exactly what it has always done, quietly, since long before there were people here to worry about it. If you'd rather have the real story than the scary one, the version with the reversed field and the 8-million-year-old rock instead of a countdown clock, that's the entire reason this channel exists. So subscribe, and the next time the internet hands you the end of the world, we'll go and find out what's actually happening down there.